Press the bell icon on the YouTube app and never miss another update.
Good morning, friends. So we have finished our last discussion of molecular orbital theory. Now, with respect to chemical bonding, we are starting the discussion of questions. Be careful, I'll be just dictating the questions, and have a look on the question properly with its proper options, and we can go with the discussions of it. The material that's in my hand is from Akash Academy. So this is precisely for JEE and Neet exams respectively. Clear, children? Right. Let us start the discussions with respect to chemical bonding. So I'll pick the first question here. Question number 1 is, the correct sequence of increasing covalent character is represented by. The correct sequence of increasing covalent character is represented by. Options that are given with this question are, so options 1, option 2, option 3, and option 4. So the 4 options that are given to you are LiCl less than NaCl less than BeCl2. LiCl less than NaCl less than BeCl2. Okay. Option 2 is BeCl2 less than LiCl less than NaCl. This option 2. Option 3 for us is NaCl less than LiCl less than BeCl2, and option 4 is BeCl2 less than LiCl less than NaCl. So the correct question is, in these 4 options, what is the correct order of increasing covalent character? Now what exactly is this question asking? Is covalent character? We have already learned that when we talk about covalent character, ionic bond is made, but in ionic bond there is some covalent character. What is the reason we what are the conditions we read for that? Was polarizing power. Correct? So polarizing power. What is polarizing here? Cation. So what are the 3 cations you have? You got Li plus, you got Na plus, and you got Be2 plus. Correct or not? What we have learned so far, polarizing power of a cation is directly proportional to charge, inversely proportional to size. Correct or not? Technically what it means, beryllium chloride, you can see that, children, chlorine is common to all. So beryllium is charge is 2 plus, right? When it is charge is more, it is tendency to pull the electron cloud towards it will be more. So polarizing power of beryllium will be more than, beryllium will be more than, correct? Li plus more than Na plus. Reason? Beryllium has more charge and size will be small. In lithium and sodium, which has smaller size? Lithium plus, because both of these have positive charge. Lithium plus has smaller size compared to Na plus, because charge is same, inversely proportional to R. So radius of lithium is less, so its polarizing power will be more. So the correct option for us will be, the order of covalent character will be BeCl2 will be more covalent compared to LiCl compared to NaCl. So that means when you talk about solubility for this question, if the question was asked out of the 4 options, what will be the order of solubility? I'm just from this question, I'm taking 3 questions. One question with respect to percentage covalent characters. What's the increasing order of covalent character? Beryllium chloride more than LiCl more than NaCl. So the correct option will be beryllium chloride more than LiCl more than NaCl. So option 2 will be our correct option. Yes or no? Now what about solubility in polar medium? Which of the three is more polar? NaCl. And which of the 3 is more covalent? BeCl2. So in polar medium, which one will dissolve more? NaCl. So what will be the order of solubility? So order of solubility in polar medium will be NaCl more than LiCl more than BeCl2. And what about children non-polar medium? What about non-polar medium? So if you got a non-polar medium, now in non-polar medium it will be BeCl2 more than LiCl more than NaCl respectively. Got it? So this is the order of solubility as well. So from this question you can get three different types of questions with respect to percentage covalent character that we have already solved out. Correct option is option 2. So if the question is with respect to solubility, you need to see whether given question is with respect to polar medium or non-polar medium. According to that, options will change. Clear or not? Right. So the question with respect to this was what? The order of covalent character. Clear? Increasing order or decreasing order? Increasing order of covalent character respectively. The correct sequence of increasing covalent character is represented by. So correct option will be BeCl2 is more covalent or less covalent? Keep it in mind. Increasing order we have to write. Yes, BeCl2 is more covalent or less covalent? More covalent. And NaCl is less covalent or more covalent? Less covalent. So which is more ionic? NaCl. So the question is increasing order of covalent character. This is decreasing order. Right. So what will be increasing order? NaCl less than LiCl less than BeCl2. So this will be increasing which character? Covalent character. This will be increasing which character? Ionic character. So correct option will be option 3 according to question. So I have taken almost 4 questions from this question into play for its discussion. Am I clear, children? Good. Next question we are taking into consideration here is, this question is with respect to formal charges. What's it? Formal charge. Question is given. The formal charge of oxygen labeled 3, 2, 1 in ozone respectively are. So we are asked to calculate formal charges in ozone, and according to the given question, so you got 2 electrons here, right? So 1, 2, 3, 4, 5, 6. That means this electron pair has been donated out, coordinate 1. So this will have 1, 2, 3, 4, 5, 6. It is 6 electrons intact. It has taken 1 lone pair of electron from other oxygen, and here it will be 1, 2, 3, 4. You got 4 here. Clear or not? Now have a look, children. Labeled 1, 2, and 3. This is 1, this is 2, and this is 3. Our question is the formal charge of oxygen labeled 3, 2, 1 in ozone respectively is. So 3, 2, 1 in ozone respectively is. So options are, option 1 is -1, +1, 0. Option 2 is 0, 0, -1. Option 3 is, what's option 3? -1, 0, +1. And option 4 is 0, +1, -1. Now have a look, children. There is a simple way to solve this question as well without doing any calculations. Look, when you look on this bond, it's a coordinate bond, right? You can see according to Lewis structure, you can easily see even if the coordinate bond is not mentioned. But according to Lewis structures, you can see there are how many electrons on this oxygen? So 1, 2, 3, 4, 5, 6, right? Has it made use of any of its electron? No. So this oxygen has obviously donated out this electron pair towards oxygen, correct? So it has gained charge or lost 1 electron, almost lost. It's a covalent bond. But electrons both have been donated by the middle oxygen, which is oxygen number 1. So naturally its charge will be +1 and this one will be -1. This will be 0. So on oxygen number 1, it is +1. Oxygen number 1, it is +1. Oxygen number 2, it is 0. Oxygen number 3, it is -1. But according to question, we have to find it for 3, 2, 1. Oxygen is 3, 2, 1. So for 3, what's the charge? -1. So this is -1, -1. So these two are eliminated. They cannot be our correct options. Now, it has -1, -1, correct? What about oxygen number 2? Charge is 0. So option number 2, which of the correct options here? 0. Here it is +1. So this will be our correct option. So option 3 will be the correct answer. Right. So that you can see very easily. Total of this ozone is neutral. Right. So this is plus, this is minus. Total charge will be 0. What about the charge of this oxygen? 0. Correct. Formal charge calculation can be done. How? Valence electrons minus shared by 2 minus unshared electrons. Let us see. Oxygen number 1. What's a valence electron? 6. How many are shared? 2 by 2 minus how many are shared? Unshared 2. Are you getting it or not? You can see that unshared electrons are 2. How many are shared? 1, 2. This bond. 3, 4, 5, 6. So it is 6 by 2 minus 2. So that will be 6 minus 3 minus 2. That will be plus 1. So for oxygen 1 it is plus 1. Yes. What about this oxygen? Valence electron 6 minus shared 2 divided by 2 minus unshared 1, 2, 3, 4, 5, 6. So that will be minus 1. So 6 minus 7 will be minus 1. So you got plus 1, this one minus 1. Total is neutral. This will be obviously 0. Want to calculate that? Valence electrons 6 minus shared 4 divided by 2 minus unshared 4. So that makes it 2, 2, 4. So 6 minus 6 makes it 0. So that is the correct answer for us. So option 3 will be the correct answer. Minus 1, 0 and plus 1 respectively on the ozone molecule. So question is, find out the formal charges on the oxygens in ozone labeled as 3, 2, 1. I already mentioned labeled 3, labeled 2, labeled 1 respectively. Clear, children? Alright. Next question. Let's see next question, children. Question is, which of the following bonds has the highest bond energy? So, unless and until mentioned, always consider bond energy. You should always consider bond energy as the amount of energy required to break 1 mole of bonds. So the other name we are usually giving to that is bond dissociation energy as well. Clear? Our question is, in the given 4 options, which of the following will have the highest bond enthalpy or bond energy respectively? Am I clear here or not? Right. So what are the options that have been given to us? According to the given question, what are the options given to us? Options given are, question is, which of the following bonds has the highest bond energy? Options are, option number 1, sulfur single bonded to sulfur. Option 2 is oxygen single bonded to oxygen. Option 3 is selenium bonded to selenium. And option 4 is tellurium single bonded to tellurium. Correct. Now, when you look on this is 16th group, right? Oxygen family. So we have oxygen, sulfur, selenium, tellurium, and polonium. So on moving from top to bottom, what happens to size? Increases. So these two are out of context for us, because in selenium and tellurium, bond, although bond length, atoms will be bigger, correct? But bond length is increasing. And due to increase in bond length, bond breaking becomes easy. So these two cannot be our correct options for us. Now looking on oxygen and sulfur, you have oxygen single bonded to oxygen and sulfur single bonded to sulfur. We will assume oxygen being smaller, bond length will be less. And in sulfur, it is bit bigger, bond length will be slightly more. So we will consider that bond energy of OO bond will be more than bond energy of SS bond. But that is not correct, because it is small and it has got lone pair of electrons on it. So you can have one more electron that may be bonded to hydrogen. So like peroxide is there, right or not? Or this will be attached. Now that can be bonded up with hydrogen. So here the size is very small and you got 2 electron pairs on it. Even sulfur will have 2 electron pairs on it, because total is 6. But the size of oxygen is bigger compared to the, smaller compared to that of sulfur. So inter-electronic repulsion in oxygen will be more compared to that of sulfur. Although bond length of sulfur is more than bond length of oxygen. But the repulsion is existing between the electrons of 2 oxygen atoms will overweigh that slight decrease of bond length for oxygen. That will make sulfur-sulfur bond dissociation difficult compared to that of oxygen. So the correct answer will be sulfur-sulfur bond will be stronger compared to oxygen bonds. Clear? Like in fluorine, F2 and Cl2, which has higher bond energies? Fluorine or chlorine? Naturally chlorine, because fluorine being smaller, repulsions are more. But if it is hydrogen and hydrogen, there you don't have inter-electronic repulsions coming into play at all. So hydrogen between 2 atoms, there is no inter-electronic repulsion. That's why the energy needed is extremely high to break a single bond of hydrogen. Am I clear, children? Right. Now you might ask me, sir, selenium is very big. So we can consider whatever the electron pairs are there on sulfur, selenium and tellurium, repulsion will be very less. But you should also understand that the first factor governing the dissociation is bond length. In selenium and tellurium, bond length is quite high. And although inter-electronic repulsions are less, but bond length is more. So that overweighs the concept of inter-electronic repulsions. So the correct option for us is sulfur single bonded to sulfur. Am I clear with this thought, children? Right? Smaller the atom, smaller will be the bond length, but more will be the repulsions of the electrons which are unshared by that particular atom. Am I clear with this? Right. Let us see next question. Question is, d pi p pi bond is present in. Question is, question number 4 to be precise. D pi p pi bond between d orbital and p orbital is present in. D pi p pi bonding is present in. Okay, so options are number 1, CO3 2 minus. Option 2, PO4 3 minus. Option 3, NO3 minus. And option 4, NO2 minus. Very simple. We need D and P orbitals overlap, not P and P. Correct? Both of these are second period atoms, carbon and oxygen. Correct? So D is not involved because when N equals to 2, L will be 0 and 1. So it is S, it is P. D is not involved. So in this carbon and oxygen, if they are pi bonding with each other, it will be p pi because both of these are second period elements respectively. So there is no involvement of D according to quantum mechanics. Clear? Next, PO4 3 minus. Oxygen does not have D, but it has P. And phosphorus, it is a third period element. So N value is 3. What is L value? 0, 1, 2. That means in phosphorus D is available. We know already. PCl5 molecule, sp3 dehybridization comes into play. Now it is S, this is P, and this is which one? D. So in phosphorus D is present, oxygen P is present. So D pi P pi bonding is possible. It is possible. I'll just make condition is possible. Whether it is possible here or not, it is definitely possible. So when it is possible, it can occur as well. But here it is not possible, so existence is not possible only. In CO3 2 minus, it cannot happen. So possibility is not here. Nitrogen, second period. Oxygen, second period. So the maximum subshell that can be present is P. D is not available, not possible. NO2 obviously not possible. So the correct option is PO4 3 minus. Now there is no need to draw the structure itself as well. Check out whether D pi P pi bonding is possible. How? When D is present, P is present. In these three, only PP is present. S and P is present, not D. So correct option will be for us PO4 3 minus. So D pi P pi bonding is possible in PO4 3 minus. Clear, sir? Right. Let us see next question. Question is, H2O is polar, whereas BF2 is not. It is because H2O is polar, whereas BF2 is not. It is because. This is question number 5. So have a look. It is asking you water is polar, but water is polar, but BeF2 is not. How will you put the reason forward for it? It's very simple. Options given here are: the electronegativity of fluorine is greater than that of oxygen. That means option 1, electronegativity of fluorine is greater than electronegativity of oxygen. Okay, this is correct. But it does not explain why water is polar and why BeF2 is non-polar. If electronegativity difference between the two is more, fluorine is more than oxygen, then according to that, BeF2 should be more polar compared to water. But BeF2 is not polar, but water is polar. So that cannot be the reason, right? Second option is, water involves hydrogen bonding, whereas BeF2 is a discrete molecule. Again, not a correct question, because hydrogen bonding does not mean the molecule will have dipole moment and molecule will be polar. Third one, water is linear and BeF2 is angular. This is wrong, because when you look on water, we know water molecule is bent. What's a hybridization? sp3. And what is the actual geometry? Tetrahedral. Oxygen, one lone pair, other lone pair, and two bonds. We have already learnt lone pair determines shape but does not participate in shape. So when you look on this, it will have a proper dipole moment or not. So it will be polar. But BeF2 molecule, BeF2, what's a hybridization? sp, right? So it will be Be, F, and F. It is linear or not? So dipole moment towards this. So in opposite direction, what's the net dipole moment? 0. So water is, third option is, water is linear, BeF2 is angular. This is wrong. Actually, water is angular and BeF2 is linear. So the correct option is fourth one, which is water is angular and BeF2 is linear. Did you get it or not? Clear, children? I've already told you, a molecule may have more electronegative atoms in it, but that does not guarantee it to be polar, because at the end, when you draw the shapes, when you see the geometry, there may be cancellation of dipole moments and net dipole moment of the molecule will be 0. Right. Next question. Question is the correct order of CO bond order among CO, CO3, 2 minus and CO2. So the question was with respect to CO2, CO and CO3, 2 minus. I reached the conclusion in that discussion that C double bond O, single bond O minus and O minus will have, it is bond order between CO as 1.33. And then if you have seen that video carefully, there I said there are two negative charges which are divided on how many oxygens? 3. So the total charge will be 0.66. So the formal charge of each oxygen is minus 0.66, minus 0.66, minus 0.66. In it is resonance hybrid, which will be a partial bond, a partial bond, and a partial bond. So oxygen's divalency is completed and carbon's tetravalency is as well completed. So the question was the correct order of CO bond orders. So what is the correct order of CO bond orders? So it is for CO2 we got 2, for CO we got 3, and for carbonate ion CO bond order means bonds between carbon and oxygen are 1.33. So the correct option will be bond CO bond order will be CO3 2 minus less than CO2 less than CO. For this it is 1.33, for this one it is 2, and for carbon monoxide it is 3, because in carbon dioxide each CO double bond, each CO bond is a double bond. Even if you want to draw the resonating structures also, we can draw two resonating structures. One will be C double bond O, so this will shift here, it will be minus, it will be plus. Or the other resonating structure you will get will be oxygen double bond carbon with plus charge, and this oxygen will have what charge? Minus charge. So total number of bonds 4, total number of resonating structures will be 2. So 4 by 2, bond order will be 2 respectively. So the correct option is option 2, that is CO3 2 minus less than CO2 less than CO respectively. Clear, children? Right. Let us see one more question. Question is, which of the following species contains 3 bond pairs and 1 lone pair around the central atom? I repeat, which of the following species contains 3 bond pairs and 1 lone pair around the central atom? This is probably question number 9. So which of the following species? Options are 1, 2, 3 and 4. So options are NH2 minus, PCl3, then you have H2O, and then you got BF3. Our question is what? 3 bond pairs and 1 lone pair. So question is 3 bond pairs and 1 lone pair. This is the question. Clear, children? We can do it in a very simple way. NH2. So we know what's the number of valence electrons for nitrogen? 5, gained 1, 6. So 6, number of bonds made 2, remaining electrons 4, that is 2 lone pairs. Our question is 1 lone pair. So this is not correct option. PCl3, We already know it, children. We have done it. PCl3. Number of valence electrons. Phosphors. 5. Number of bonds made. 3. Remaining electrons. 2. That is 1 lone pair. So how many bond pairs you got? 3. And how many lone pair you got? 1. So P with a lone pair of electron. Then bond with chlorine. Bond with chlorine. Bond with chlorine. What are these 3? Bond pairs. And what is this one? Lone pair. So how many bond pairs on the whole? You got 3 and 1 lone pair. 3 bond pairs and 1 lone pair. PCl3. Correct option so far for us. Water molecule. Water molecule. How many lone pairs? 2 lone pairs. So out of context. BF3. No lone pair. Because BF3 molecule will be valence electron is 3, bonds made 3, remaining electron 0. So there is no lone pair of electron at all. Now see what I am doing, children. I am not reaching direct answer here. What I am doing is, although I can reach answer directly and tell you the correct option is PCl3 and do for PCl3, but I am not doing that. I am exactly checking out all the 4 options with the number of lone pair and bond pair calculation. If you have seen other 6 or 7 questions that I discussed, I am not discussing a single correct option. I am discussing why other 3 are wrong and why 1 correct option will come into play respectively. Clear? So I am not just going directly with the answer here at all. So we are solving and reaching the answer, and we by means of our logic are defying why others cannot be the correct option. That technically means if we solve 20 questions, that is technically 80 questions, because I am discussing all the 4 options. Clear? Right. Very good. So let us move on to the question number 10. Yes. Question is, which one of the following pairs of chemical species contains the ions having same hybridization of the central atoms? Which one of the following pairs of chemical species contains the ions having same hybridization of central atoms? So we have our options. What are the options, children? So options are NO2 minus and NH2 minus. Option 2 is NO2 minus and NO3 minus. Option 3 is NH4 plus and NO3 minus. And option 4 is SCN minus and NH2 minus. This is the question. So these are the 4 options we have. What are these? NO2 minus and NH2 minus, NO2 minus and NO3 minus, NH4 plus and NO3 minus, SCN minus and NH2 minus. What's the question asked? Question asked is, which one of the following pairs of chemical species contains the ions with the same hybridization of central atom? Same hybridization of central atom we can see here, NO2 and NH2. For NH2 and NO2 difference is very clear. Nitrogen, I'll make it term NO2 minus and NH2 minus. We'll do for nitrogen, valence electrons 5, gained 1, 6, bonds made 2, remaining 2 lone pairs and 2 bond pairs. NO2, nitrogen 6, bonds made 4, remaining electrons 2, that is 1 lone pair, minus 2 sigma bonds, because 2 will be pi with NO2, right? Or with oxygen divalency, 2 will be pi and 2 will be sigma. So 2 sigma bonds and 1 lone pair. Total 3 hybridization, sp2. This one is sp3. So not a correct option. First one is not a correct option. NO2 we found a while earlier. What is this one? sp2. What about NO3 minus? We can do that very simple. NO3 minus, nitrogen, valence electrons 5, gained 1, 6, bond is made 6, remaining electron 0, minus 3 pi, because with oxygen it will make 2 bonds. Total number of sigma bonds will be 3 sigma bonds. Hybridization sp2. NO2 is sp2, NO3 is sp2. So our correct option will be option 2. NO2 minus and NO3 minus will have the same hybridization of central atom. Although shape wise also they will be different, because if you look on NO2, one position will be occupied by lone pair. It will be bent. It will be like this, N double bond O, and let us suppose this is a coordinate bond, because coordinate bond if you make and double bond if you make, anyway you have to take only one into consideration for hybridization, and there will be 1 lone pair of electron. You can see 1, 2, 3, 4, 5, 6 by gaining 1 electron. There's a minus charge on it, right? So actual arrangement for sp2 hybridization is what? Triangular planar. but one position is occupied by lone pair, so shape will be bent. What about NO3 minus? Very simple. N double bond O, O double bond O. So again, there is no lone pair. Hybridization sp2 triangular planar. According to shape, I'm talking about geometries. The correct option NO2 minus and NO3 minus respectively. What about NO3 minus? We proved sp2. What about NH4 plus? sp3. Simple, children. NH4 plus nitrogen valence electrons 5. It has lost one, so 4. 4 bonds made, remaining 0. So hybridization sp3. So correct. This will be wrong. This obviously is wrong as well, because SCN will be sulfur bonded to carbon, triple bonded to nitrogen. Yes. So here carbon is under what hybridization? Central atom is carbon. Yes. So carbon is under what hybridization? sp only. And NH2 we have proved is sp3. So what's the correct option for us, children? NO2 minus and NO3 minus respectively. Very good. Move to the next question. Question is, in the given hydrocarbon which I am going to draw, I will take variety of questions into consideration so that multiple topics and multiple variations are checked. Clear? So we have a hydrocarbon given, and we are asked in that given hybridization, in the given hydrocarbon, what is the hybridization of different carbons? Am I clear, children? Right. Let us see the questions. Hydrocarbon given is CH3, CH, double bond CH, single bond CH2, single bond C, triple bond CH. Okay. The state of hybridization of carbon 1, 3 and 5. Carbon 1, 3 and 5. Yes, is. So options for you are 1, sp3, sp2, sp. Option 2 is sp2, sp, sp3. Option 3 is sp, sp3, sp2, and fourth option is sp, sp2, sp3. These are the 4 options we have. Question is carbon number 1, 3 and 5. What's a hybridization? So this question can assess, or this question can check your 2 rules. 1, IUPAC nomenclature locant rules, and how to number a carbon chain, and according to that you can, after that you can find out hybridization quite easily. Am I clear, children? Right. So let us see this thing out. So numbering has to be done from the triple bond side because this is closest to chain. 1, 2, 3, 4, 5, 6. So our question is carbon number 1. It's a triple bond, right? This carbon has made how many bonds? 2 sigma bonds, one with hydrogen and one with one more carbon. So this has to be under sp hybridization. So I will write down here, carbon 1 is under sp hybridization. So it is sp3, it is sp2, it is sp, it is sp. So option 1 and option 2 are eliminated. Clear? Right. Now, what about carbon number 3? So this is carbon 2, this is our carbon number 3. 1 bond with hydrogen, 1 bond with hydrogen, and 2 with carbons. Correct? Total how many sigma bonds? 4. So what should be the carbon number 3 hybridization? sp3. So we got sp and you got sp3 here, right? What's the option here? sp2. So this is eliminated. Correct option will be this one only. So it will be sp, sp3, sp2. Let us see carbon 5. Carbon 5 is double bonded, right? So one side bond, other single bond with hydrogen, other single bond with carbon, and there is one pi bond. So total sigma bond is 3. Hybridization will be sp2. So the correct option will be option 3. Is it clear, children? Right. So if the question was like this, Instead of that, you have a double bond at this position rather than this position. You had a double bond here. Then when numbering was to be done, double bond will be preferred. So numbering has to be done from this side. That would have made question a bit more trickier. So if you have been mentioned carbon 1, carbon 3, carbon 5, it's easy. If it is not mentioned, then IUPAC nomenclature and IUPAC rules have to be taken into consideration as well during solving the question. Right? So the correct option for this one will be option 3. Good. Next question, children. We have which compound has planar structure? Which compound has planar structure? So this is question number 12 or 11. You can have a look onto that. So what are the options you have given? 2, 3, 4. What is question? Planar structure. We'll see that. Question number 12 it is. Options are, children, XeF4, xenon tetrafluoride. Second option is XeOF2. Third one is XeO2F2. And fourth one is XeO4. Right, let us see this one. So we have to find out planar structure for this, right? First of all, we'll find out hybridization, number of lone pairs and bond pairs. According to that, we can find out the geometry and shape of the molecule. Let us see the first one. XeF4, right? Use the rules. Valence electrons 8, bonds made 4, remaining electrons 4. That means 2 lone pairs. And how many bond pairs? 4. That means 4 sigma bonds, and it can make 2 more. Total hybridization will be sp3d2. Now children, tell me, for sp3d2 hybridization, what is the normal geometry that we will draw? Octahedral, right? Square planar bipyramidal. So what will be the molecule here? So we'll get fluorine, 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 right? So you got 1 fluorine, 1 more, 1 more, 1 more, total fluorines. Then there are how many lone pairs? 2. Get back to the discussions. Clearly mentioned that whenever there is lone pair in sp3d2 hybridization, it should be given at what position? Axial positions, means out of the plane it should be given, above and below the plane. So this is 1 lone pair of electron I am giving, and this is 1 more lone pair of electron I am giving. So according to this, if you see the geometry of the molecule will be, this is a square plane, and 1 above the plane, 1 below the plane, square planar bipyramidal. But we know lone pair only determines the shape, but does not participate in the shape. So what I will do is, I'm going to remove the lone pair of the electrons, because they will have the impact on the shape, but I will not show those, because in the structure I will show only what? Bonds, right? So you can see this molecule very clearly now. If I start to draw from first picture itself, I will be able to draw a square planar structure. So this has a planar structure. This will be the correct option for us. What about XeOF2? I'll solve all the 3 for you. So XeOF2. Xenon, how many valence electrons? 8. How many bonds made? 4. Because xenon will make 2 bonds with oxygen and 2 with fluorine. Rest of the electrons which are there, how many total? 8. 2 with oxygen, 2 with fluorines. So 1, 2, 3, 4. 4 will remain. That means how many lone pairs? 2 lone pairs. From this also it comes the same. 4 bonds made. That is 4 electrons remaining. That is 2 lone pairs. Correct? 4 bonds, out of which 1 will be pi. So 3 sigma. You are following or not? So 1, 2, 3. 3 sigma bonds plus 2 lone pair. Total 5. So hybridization sp3d. Now in sp3d structure, you got how many lone pair of electrons? 2. Why should you give the lone pair of electron when it is sp3d hybridization? Axial or equatorial positions? Equatorial positions. So how many lone pairs we have here? 2. I will give those lone pairs. Now you got here 1 lone pair, right? Second lone pair. Clear or not? Then I will give 1 double bond with oxygen. So I have completed triangle. So you see, triangular planar structure is complete because I am drawing geometry. Now, how many lone pairs are there? 2. I have drawn it already. Now, how many bonds left out? 2. So 1 I will give above the plane. Consider this to be above the plane, and 1 below the plane. Right or not, children? You can see that very easily. The molecule is not planar, rather it is T-shape. The handle of the T is a double bonded oxygen. And in case of hybridization, this is considered to be one entity only. Am I clear? So what's the structure? T shape. So is it planar? No. What about XeO2F2? Very simple now. Make it XeO2F2. Now instead of 4 bonds, how many bonds will be there? 6. So now there is one more double bond with oxygen, right? And then there will remain one lone pair of electron. You can do that. 8, 6. How many electrons remaining? 2. That is one lone pair. So how many sigma bonds made? 1, 2, 3, 4. Number of sigma bonds are 4 because obviously 2 are pi. 4 sigma bonds and one lone pair. Again hybridization, sp3d. Now triangle was completed a while earlier. I will draw that again. How many lone pairs I have now? How many lone pairs I have now? Only one lone pair. Yes or no? So I will draw that. Drawn one lone pair. Correct. In which position? Equatorial position. How many bonds I have to give? 2. I will give double bond to oxygen and double bond to oxygen. At least 120-degree difference I have kept. Triangle planar completed. Hybridization is sp3d. What's the actual geometry? Triangular planar bipyramidal. So above the plane what you will have? Fluorine. Below the plane what you will have? Fluorine. Now you remove the lone pair of electron. What's the geometry? Hybridization is sp3d. What's the geometry? Geometry is triangular planar bipyramidal. Now once I remove the lone pair, what's the shape? Seesaw. I have already told you these things, how to calculate it out, right? So is it a correct option? No. What about XeF4? It will be definitely tetrahedral. Want to see? Xenon. Double bond oxygen, double bond oxygen, double bond oxygen, double bond oxygen. Any lone pair of electron existing? No. Because you can also do it. 1/2 of valence electrons, 8. Number of bonds made. How many monovalent atoms? Children, 1/2 of V plus M minus C plus A. No monovalent atom, no cation charge, no anion charge. Valence electrons, 8. That will be 4. Hybridization will be definitely sp3. So what will be the structure of that? XeFO4, it will be Xe double bond O, double bond O, double bond O, and double bond O. So this will be a perfect tetrahedral structure for us. So correct option will be XeF4. Are you getting it? So why I am doing it in a previous full-fledged discussion? Otherwise, right first time only I got the answer XeF4. But every one of you should understand. See children, actual answer is XeF4. I got that out. But these 3 options that I have solved for you are having sp3d hybridization and the shapes of the molecules are completely different. And the last one is having sp3 hybridization only. So anytime you are solving any question, MCQ practice does not mean reaching the answer. MCQ practice means reaching the answer and also by logic define the other 3. You should be in a position to define other 3. You should be in a position to tell why other 3 are not the correct options for it by solving all the 4. If you got one correct and about other 3 you are not knowing it at all, then that does not mean you are fully prepared for things. Keep it in mind. Right, children? Very good. Let us move into the next question. We'll go into question number 13 now. Right, children? So different style questions we are solving. So keep practicing hard. Right. We move into the next question. Question number 13. Right, children. In which of the following bond angle is maximum? Question number 14. Bond angle is maximum. Options are NH3, option 2 NH4 plus, option 3 PCl3, option 4 SCl2. Now tell me, if you want to find out maximum bond angle, should there be lone pair into play or not? A basic question I'm asking you. If lone pair is there, what does it do? It squeezes the bond and bond angle will decrease. How? Suppose if you have Methane, hybridization sp3, bond angle 109 degrees, 28 minutes. If you have ammonia, one lone pair comes, then the other three bonds will squeeze and it becomes 107. And if it is water, there are two lone pairs, it becomes 105. So bond angle is decreasing. More the number of lone pairs, lesser the bond angle. Clear? Here you can find it very easily. Whichever will contain lone pair of electron, and if the hybridization is same, bond angle will not be remaining same. Now ammonia molecule, we know hybridization is sp3. It contains one lone pair of electron. And what is the angle in ammonia? Nitrogen with one lone pair of electron, it squeezes the bond in and bond angle becomes how much? 107 degrees only. But in CH4, it is how much? 109 degrees. Because there is no lone pair here at all. Now ammonium ion, nitrogen, valence electrons 5, it has lost one, so 4. Bond is made 4, remaining electron 0. So no lone pair, hybridization sp3. Here also sp3. How can you do that? Valence electrons 5, bond is made 3, remaining electrons 1 lone pair. Yes. Here any lone pair? No. Hybridization sp3. Bond is made 4. Here how many bonds is made? 3. With one lone pair it can make 4 bonds. But one lone pair will squeeze the bond in. Bond angle will change. Here it's a normal sp3 bond angle. That is 109 degrees 28 minutes. PCl3. Phosphorus will contain one lone pair. Hybridization will be sp3. Again bond angle will decrease from the normal 109 degrees. And SCl2 will have 2 lone pair of electrons. Sulfur 6 bonds made 2. Remaining electrons 4. That is 2 lone pairs. So sulfur will be like this. Water molecule. So like water molecule, it will be bent. Also hybridization here also is what? sp3. But bond angle will be very less. So maximum bond angle is present in NH4 plus, where there are no lone pair of electrons present. Is it clear, children? Very good. Next question. Question number 15. Question is, the correct order regarding the electronegativity of hybrid orbitals of carbon is. The correct order regarding the electronegativity of hybrid orbitals of carbon is. So option number 1, sp less than sp2 less than sp3. Second option, sp more than sp2 less than sp3. Option 3, sp more than sp2 more than sp3. And option 4 is sp less than sp2 more than sp3. Clear? These are the 4 options given. We already know. More the S character, more the electronegativity. In sp, so S character is more, electronegativity is more. Reason? Penetration. Because S is more penetrating than P, then D, then F. So when S character is more, the bond will try to be more towards nucleus. So penetration tendency towards nucleus by S orbital is more. Naturally, that means its electronegativity will also be more because nuclear pulling property will be more. So S character is 50%. P character is 50%. Which of the hybridized orbitals has maximum S character? Only sp. So it will be sp more than sp2 more than sp3. So correct option will be which one, children? Sp more than sp2 more than sp3. Because here S character 50%, here only 33%, and here only 25%. So correct option will be option 3 for us. Right? Correct. Next question. In which of the following molecules all the bonds are not equal? This is very good question. In which of the following molecules all the bonds are not equal? Is it clear? In which of the following all the bonds are not equal? Let us see the options. Question number almost 17. So options are NF3, option 2 CLF3, option 3 BF3, and option 4 PF3. What's the question? In which all the bonds are not equal. All the bonds are not equal. This is a good question. First of all, if there are two types of bonds present for you, one is axial and one is equatorial. Repulsion between equatorial and axial bonds is at what degrees? 90 degrees. Between equatorial and equatorial bond is 120 degrees, provided it is sp3 dehybridization. Clear? Good. Now when you look on NF3 molecule, N with a lone pair of electron and normal tetrahedral geometry should be there, but due to presence of lone pair of electron, it will be pyramid. Squeezing of all the bonds is same, so there is no axial equatorial positions at all. All the three are directed like this. So you got nitrogen here, one this way, one this way, one this way. All the three bonds are finding out equal repulsion from lone pair of electron. So obviously the bonds will not alter in their strength respectively at all. Clear? All the bonds will be of same strength. Am I clear? Number 2. ClF3. So ClF3, chlorine 7, bonds made 3, remaining electrons 4. That is 2 lone pair of electrons. And how many bond pairs? 3. So hybridization will be sp3d. This is good. Now children, tell me, in ClF3 how many lone pairs you got here? 2. So where you will give the lone pair of electron? Axial or equatorial positions? You will give those at one here, equatorial position, and one you got fluorine downwards. So triangle completed or not? Right. Now what is this one here? This is again fluorine, this is again fluorine. We know ClF3 molecule has what shape? T shape. Now what are these? Lone pair of electrons. Very good. Now see here. This is what position? Axial or equatorial? These are axial position, and these three are what? Equatorial positions. What is this angle? 120 degrees. And what is this angle? 90 degrees. Because you got lone pair here and you got bond pair above the plane. So what is the angle here? 90 degree. You got one lone pair here, one lone pair here. What's the angle here? 120 degrees. So this angle is what degrees? 90 degrees. This angle is what degrees? 120 degrees. Clear or not? Now tell me, this is what position? Equatorial. And this is all these three positions are what positions? The three positions I have mentioned out here. So what are these three positions? They are equatorial positions. Clear or not? And what are these two positions? Axial positions. Now repulsion between lone pair and bond pair at 90 degree will be more or less? More. Here also it will be more. Now due to more repulsions between the axial bonds and the lone pair of electrons in the plane, what happens? This molecule, this bond between Cl and fluorine will be bit tilted. So what happens by that is Cl gets fluorine this here and one more fluorine here, and down there is one fluorine. That's why sometimes it has arrow type of structure also. So you got fluorine here, you got fluorine here, you got fluorine here, and you have one lone pair of electron in this position. You have two lone pair of electrons to be precise, children. Two lone pair of electrons existing. Now repulsion existing between lone pair and this is same to that of this one and this one? No. In equatorial position repulsions are less, but between axial position and equatorial position repulsions are more. So naturally these two bonds will be of different strength compared to this one. So in ClF3 molecule, definitely the bond strength will be altered. What was the question that was asked to us, children? Question was, in which of the following molecules all the bonds are not equal? So obviously these bonds will be altered in length compared to which bond? Because I said about strength, and strength is dependent upon length itself, right? So in ClF3 definitely all bonds will not be of same strength and will not be all equal, right? What about BF3? Simple. BF3 is a very simple molecule. All bonds are same, right, children? No axial, no equatorial position, triangular planar, triangular planar lone pair of electron. And fourth one is BF3. It's like ammonia only. It's like NF3 only with one lone pair of electron. PF3 with one lone pair of electron. Again, P, fluorine, fluorine, and fluorine with a lone pair of electron here. So correct option will be ClF3. Am I clear here, children? Very good. Let's move into the next question. In a regular octahedral molecule MX6, the number of XMX bonds at 180 degrees is. In a regular octahedral molecule MX6, regular octahedral molecule MX6. What is the number of MXM bonds of 180 degrees? Okay, MX6, regular octahedral structure. The number of XMX bonds at what degrees? 180 degrees are options 1, 3, option 2, 2, option 3, 1, and option 4, 6. Right, children? So 3, 2, 1, and 6 are the options which are given to us. Clear? Now, we will draw a regular octahedral structure. Metal in the middle, above the plane X, below the plane one more X, and 4 in the plane. Right? So we will see the number of angles at what degrees? 180 degrees. Now tell me, this is above the plane. I'll draw this structure more clearly. Above and below the plane. This angle is what degrees? 90, 90, 90, 90. This angle is XMX, 180 degrees. This one is also 180 degrees. And this one obviously is at what degrees? 180 degrees. So the total number of angles at 180 degrees are how many? 3. Yes, very good. Next question. In NO3 minus ion, number of bond pair and lone pair of electrons on nitrogen atom are. In NO3 minus ion, what is the number of lone pairs and bond pairs on nitrogen? That's a question asked. Options are 2, 2. Option 2 is 3, 1. Option 3 is 1, 3. And option 4 is 4, 0. These are the options given. So I'll repeat options. 2, 2, 3, 1, 1, 3, and 4, 0 are the options given. So we have number of lone pairs and number of bond pairs. Sorry, I'll see the question. Number of bond pairs. So number of, because option way it is different. Bond pairs and lone pairs on nitrogen atom. To do that, it's very simple to analyze out. Nitrogen, double bonded to oxygen. We have been drawing the structure now. O minus, and there is one coordinate bond. Total number of electrons on nitrogen are how many total? 5. How many it has used? Coordinate bond 1, 2, 3, 4, 5. No lone pair of electron on nitrogen at all. So there is no lone pair. So this should be 0 lone pair. And obviously there is only one option with 0 lone pair. Number of bond pairs will be 4. So correct option is 4. You can see that 1, 2, 3, 4. There are 4 bond pairs, including sigma and pi bond, all. So there are 4 bond pairs, and there is no lone pair on nitrogen. Clear or not? So correct option will be 4 and 0. Very good. Because there are same types of questions repeated. Which of the following would have a permanent dipole moment? Question is, which of the following will have a permanent dipole moment existing in the molecule? Yes. So you can see those dipoles coming into play. So how do you find out exactly the dipole moment on a molecule, children? It has to be simply understood. Let us see. So you have question number 20 asked here. Which of the following would have a permanent dipole moment? So options are, first option given is SiF4, second option given is SF4, third option is XeF4, and fourth option is BF3. So question is, which of the following will have a permanent dipole in it? Now, last time in my discussions, what I discussed out was that to find out a permanent dipole, you first of all need to find out the geometry of the molecule itself, right? And after geometry, you can find out the shape, and according to that, dipole moment can be found out. SiF4, if you look on, silicon, how many electrons are there total in the valence shell? 4, bond is made 4, remaining electron 0. Hybridization is sp3. Hybridization sp3 means Si, you got fluorine, you got fluorine, you got fluorine, and you got fluorine. All will cancel down the dipole moments. Net dipole moment will be 0. So this will be having dipole moment of 0. SF4, sulfur, fluorine, sulfur valence electron 6, bond is made 4, remaining electrons 1 lone pair. So total hybridization will be sp3d. Clear or not? And when you look on SF4 molecule, we have already learned it out. sp3d with 1 lone pair. So this is 1 lone pair. This is fluorine. This is fluorine. Because we have to give lone pair in the plane. Correct or not? I have given that. So this is fluorine. This is fluorine. 1 fluorine above the plane. 1 fluorine below the plane. What's the shape? Seesaw. Now, the dipole moment of fluorine will cancel. You can see that dipole moment is going towards fluorine, and here it is going towards fluorine. The 2 will cancel. Now, 2 fluorines and 1 lone pair of electron which is existing. The net dipole moment of the 2 will be downwards, and here the net dipole of lone pair of electron will be upwards. We have learned it out. But there will be no cancellation between lone pair of electrons and bond pair of electrons. As a result of that, net dipole moment will not be 0. Right? And XeF4, a while earlier, the question which I solved, what did I found out there? XeF4. What's the shape of this molecule? Geometry. Hybridization is sp3d2. Right or not? It should be octahedral, but lone pair above and below the plane. So what was the actual shape coming? Xe, fluorine, 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 and fluorine. You can see net this direction, cancellation will occur. Net dipole moment will be 0. Or opposite directions, cancellation will occur. Net dipole moment for this also is 0. This will, dipole moment will not be 0. It is dipole moment will be definitely 0. And BF3, whole world knows it. Boron, hybridization is sp2. Fluorine, fluorine, fluorine. The upwards, net addition, net dipole moment will be 0. So correct option for S will be SF4. Clear or not, children? Question number on the paper is 28. So question is, main axis of a diatomic molecule is Z. So almost this is question number 20 or 21 of our discussion. Question is asking, main axis of molecule is Z. Main axis of diatomic molecule is Z. Orbital px and py overlap with each other to form which of the following molecular orbitals? Orbitals px and py overlap to form which of the following bonds? Options are, first option is pi molecular orbital, second is sigma molecular orbital, third one is delta molecular orbital, and fourth one is no bond is formed. So main axis of a diatomic molecule is Z according to the question. So if main axis of a diatomic molecule is Z, that means px and py will be making what bonds? Pi bonds. But according to molecular orbital theory, px can overlap with px, py can overlap only with py because of symmetry considerations according to MOT. Correct or not? But here it is telling px and py overlap and will make which of the following bonds? So obviously there will be no bond formation between the two. So correct option will be 4 because the two are out of symmetry. Clear? Px can overlap with px, py can overlap with py to result in the formation of bonds. So here there will be no bond formation. Clear? Next question. Question number 21. Question number 21 we'll take. It is N2 and O2 are converted into monoanions N2 minus and O2 minus respectively. So our question is N2 and O2 are converted to monoanions N2 minus and O2 minus respectively. Which of the following statement is wrong? So out of the given question, which statement is wrong? So options are: in O2 minus, bond length increases. Option 2, N2 minus becomes diamagnetic. Option 3, in N2 minus, the NN bond weakens. And option number 4, in O2 minus, the OO bond order decreases. So I will give you the hints of the options with respect to this. What are the options given? Option 1 is, in O2 minus, bond length increases. This is first option. Second option is, N2 minus becomes diamagnetic. Third option is, N2 minus, in N2 minus, NN bond weakens. And fourth one is, in O2 minus, bond order decreases. Our question is, which of the following? So N2 is converted to N2 minus and O2 is converted to O2 minus. Which of the given options is wrong? Correct or not? Which of the following statements is wrong? We have to find it out. A very simple thing. Now in bond length, when you are calculating, so obviously you need bond order first. So first, for O2 minus, bond length is increasing. What should happen for it is, for O2 to O2 minus, if bond length is increasing, it means bond order should be decreasing. That's a very simple phenomena. Clear? Now look on oxygen. We know when oxygen is converted to O2 minus, electrons are added to bonding or antibonding. They are added to antibonding, and we already know when the electron is added to antibonding, because children, the outer electronic configuration of O2 is what? It is sigma 2pz2 less than pi 2px2 less than pi 2py2 less than less than pi star 2p y1 equal to pi star 2pz1. This is the outermost electronic configuration of oxygen. Now if you want to see that also, children, I will show you for oxygen and nitrogen diagrammatically. So it will be a longer aspect of it, but we need to solve it out. So if you have seen the diagrams clearly, this is the diagrammatic analysis, electronic configuration. So I won't draw for 1s and 1s, 2s and 2s. I will go directly with oxygen. Suppose it is nitrogen and it is oxygen, right? So 2px, 2py, 2pz, 2px, 2py, 2pz. For oxygen also 2px, 2py, 2pz, 2px, 2py, 2pz. Oxygen's electronic configuration outermost is 2px2, y1, z1. Here also 2, 1, 1. But for nitrogen it is 1, 1, 1 and 1, 1, 1. We know nitrogen's atomic number is 14 and oxygen's atomic number is 16. So what is the diagrammatic representation for nitrogen, children? So in nitrogen, what will happen? What will be down and what will be up? Nitrogen with atomic number 14. What will be down? Sigma or pi? Pi will be down, sigma will be up. Here, pi down, sigma up. We already know it. In oxygen, atomic number is more than 14. So what comes down? Sigma. What goes up? Pi. And antibonding orbitals, how it is? Pi will be always down, sigma will be up. Now, tell me what is this? Pi 2px equals to pi 2py, and this is sigma 2pz. Here, pi star 2px, this is pi star 2py, this one is sigma star 2pz. Total electrons 14. 1s, 1s, 2s, 2s, I have neglected, I have not taken into consideration. Because 1s, 1s, 2, 2, cancel. 2s, 2s, 2, 2, cancel. So now, how many total electrons? 6. All the 6 electrons will go to bonding or antibonding? Bonding. So tell me the number of electrons in bonding orbital. Sigma 1s2, then sigma 2s2, then these 6, total 10 minus 4 divided by 2, that will be equal to 3. So nitrogen's bond order is 3. Now according to question, nitrogen changes to what? Nitrogen minus. It has gained 1 electron, correct? Where will that electron go? Anti-bonding. So in nitrogen minus, electrons going in anti-bonding. We have already learned when electron is added to anti-bonding, bond order decreases by 0.5. So you got 3 as a bond order. It will convert to 2.5. Let us see options for nitrogen. Nitrogen becomes diamagnetic. Wrong. Nitrogen is, a while earlier, nitrogen was diamagnetic. But once the electron is added, it becomes N2 minus. It becomes paramagnetic. This is wrong option. This is wrong. Now, in O2 minus, bond length, in O2 minus, bond length is increasing or decreasing according to given option. In O2 minus, bond length increases. So bond length increases means what? Bond order should decrease. Correct or not? Bond order should decrease. Let us see oxygen. 2 plus total electrons, how many? 8. So obviously 6 will go to bonding. How many remain here? 2. 1 will go to pi star, 1 will go to pi star. Total 8, right? Now tell me, what is the bond order of oxygen? We already know it is 2. How? 10 minus 6 divided by 2, which is equal to 2 bond order. Why 6? But anti-bonding 1s2. Then anti-bonding 2s2. Then anti-bonding pi star 2px2, pi star 2py, sorry, pi star 2px1, pi star 2py1, right? 2 electrons. So bond order is how much? 2. Now see for oxygen. According to question, O2 minus, bond length is increasing. That means bond order should decrease. What's the bond order here? 2. Now, if it becomes O2 minus, 1 more electron will be added or not? Correct or not? So what's the number of electrons in anti-bonding now? 7. 2 will become 1.5. So bond order decreases or not? Bond length will definitely increase. This is correct option. Now, third option. N2 minus, N bond weakens. That is correct. Why? Because what was bond order while earlier for nitrogen? 3. What about nitrogen minus? It is 2.5. Bond order has nitrogen minus 2.5 because electron is added to anti-bonding. So when bond order has decreased, naturally what will happen? Nitrogen bond will weaken. When bond order decreases, bond strength will also decrease. This is also correct option. In O2 minus, bond order decreases. What's our question? In O2 minus, last option we'll see. In O2 minus, oxygen bond order decreases. In O2 minus, oxygen bond order decreases. This is again bond order. Decrease or not? Yes, because in O2, what's a bond order? 2. In O2 minus, what's a bond order? 1.5 only. And you can see that here. Bond length is increasing. That means bond order will decrease. This is also correct. So our correct option will be N2 minus. Right, I have said earlier only, children, I'm not discussing direct option here at all. So I'm checking all the 4 options with respect to the discussion clearly. Got my point or not? Very good. Next question. Question is, which one of the following species does not exist under normal conditions? Which one of the following or which of the following species will not exist under normal conditions? So if you have been given a molecule and you are asked whether it will exist or not, what is the basic thing that we all need to do? We need to calculate what? Bond order. Am I correct or not? So when you will calculate bond order and you see bond order is positive, such a molecule is possible. If bond order comes to be negative, molecule will exist or not? No. Question is, which one of the following species does not exist under normal conditions? So your options are Li2, option 2 is Be2 plus, option 3 is Be2 and option 4 is B2. Now if you have understood the discussion that I have done, we have seen there for Be2 bond order is 0. Since Be2 bond order is 0, this molecule will not exist. B2 will exist because bond order is 1. In B2 plus, Be2 will not exist, but B2 plus will exist with a bond order of 0.5, and Li2 we know the bond order will be 1. I want to see diagram. Have a simple look. Lithium 1s2 2s1. So how will it be? 2 2 2 2. Then 1 1. There will be 2 electrons in bonding, right? So 2 minus antibonding how many? 2 plus 2 4. Antibonding 2 divided by 2 equals to 1. That's it. B2 0. How? Have a look. Hydrogen, helium, lithium, beryllium. It is 1s2 2s2. Look on the diagram. This is energy. So 1s 1s. Then 2s 2s. Correct? So bonding, anti-bonding. Here, bonding, anti-bonding. One has how many? 2 electrons, 2 electrons. Here it will go 2, 2. Here, 2, 2. Here again, 2, 2. How many electrons in bonding? 4. Anti-bonding, 4. Bond order will be 0. So this molecule is not going to exist. B2 we have already seen in molecular orbital diagram. For B2 bond order is 1. So correct option will be BE2. Will not exist under normal conditions. Right, children? Next question. Right. So which of the following molecule stabilizes by removal of electron? Which of the following molecule stabilizes by removal of electron? So options are A. Which of the following molecule stabilizes by removal of electron? Very simple. If it is stabilizing by removal of electron, that means it should be removed from antibonding. So what are the options given to you? You have C2, option 2 is O2, option 3 is N2, and option 4 is H2. Definitely answer will be O2. What's the reason? Because in O2, when you remove the electron and convert this into O2 plus, electron will be definitely removed from antibonding. In all of these, electron has to be removed from bonding. You can see the diagrams, molecular orbital diagrams of the 4. You can easily see in oxygen only the electron has been removed from where? Bonding or antibonding? Antibonding. That's what it will do. Removing the electron will stabilize the molecule on the whole. Clear, children? Very good. Question next. Which one of the following has strongest OO bond? Strongest OO bond. So this was question number 25 almost. Question number 25. Strongest OO bond. What are the options? Options are O2 plus. Option 2 is O2. Option 3 is O2 minus. And option 4 is O2 2 minus. This is a simple thing to do. Right, children? Now we know for O2 what is bond order? 2. Very good. Now when you remove one electron from oxygen, this is bond order. When you remove the electron from oxygen, are you removing it from bonding or antibonding? Antibonding. Which antibonding? Pi star 2px1 equals to pi star 2py1. So you will be removing one of the electron from antibonding. Once you remove electron from antibonding, bond order will increase. So bond order becomes 2.5. Next, in O2 minus, electron is being added to antibonding because antibonding is free there. If you look on the diagram of oxygen, antibonding is free there. Bond order becomes how much? 1.5. And for O2 2 minus, bond order becomes only 1. If you want to see that also, tell me, children, what is the bond between fluorine and fluorine? Single bond. How many electrons in fluorine? 9. Here also 9. 9 plus 9 equals to 18. Oxygen is 16. 16 and gain to 18. Number of electrons are same. Thus bond order of the two will also be same. So we can see here that in O2 plus, bond order is the maximum, and in O2 2 minus, it is the least. What's the question asking you? Question is asking you, which one of the following has strongest OO bond? So the correct option will be O2. Why? Strongest OO bond means bond dissociation energy should be more. Then our bond order should also be more, because we have learned bond order, bond dissociation energy is directly proportional to bond order. We have learned it already, children, according to our discussions. Am I clear with this thought here? Yes or no? Correct. Let's continue. Yes. So our next question here is question number 26. What's the question? So I have done a direct calculation, so it should be easier for all of you to do it. Yes. We have a question here. Which molecule contains both polar and non-polar covalent bonds? Which molecule contains both polar and non-polar covalent bonds? So your options for this are A, question number 26 it is. Option 1 is NH4 plus. Option 2 is HCl. Option 3 is CH4. And option 4 is H2O2. This is the question asked. Right? Now, according to this question, we are asked which of the following molecule contains both polar and non-polar covalent bonds. Let us see. NH4 means N, H, 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 and one coordinate bond to H. All of the bonds are what? Covalent bonds, right? HCl, we know this bond is a perfect polar covalent bond. Charge separation between the two, electron density more towards chlorine. CH4, we know it's perfectly non-polar, and all bonds are non-polar. In H2O2, when you look on the structure, how is it? There's a link between oxygen, then there's a link with hydrogen, then there's a link with hydrogen. So what is this bond? It is polar. And what is this bond? This is non-polar. Because between two similar atoms, what is the bond? Polar or non-polar? Electronegativity difference is 0. So it will be non-polar bond, and this one will be polar, because oxygen, hydrogen, which is more electronegative? Oxygen. So this bond will be polar, this bond will be polar, and this bond will be non-polar. So correct option is fourth one, that is H2O2. Correct. Next question. Which of the following molecule is polar? Which of the following molecule is polar? This is important question. Have a look on this carefully. Question is, which of the following molecule is polar? We have learned, children, what? That a molecule's individual bonds can be polar, but the net dipole moment existing, net polarity existing in the molecule may be 0 as well. We have learned that out clearly in our previous discussions. Very good. Let us see. Which of the following is a polar molecule? 1. Option 1 is para-dichlorobenzene. So para-dichlorobenzene means chlorine and chlorine. Second option is carbon tetrachloride, Cl, 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 and Cl. Option 3 is tetrachloroethene, so C, double bond C, Cl, 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 Cl. And option 4 is para-hydroxybenzene. You can say it in trivial names. You got OH and you got OH here. Now look on the molecule. So here dipole moment towards chlorine, here dipole moment towards chlorine, net dipole moment 0. That's understood to us. This is polar or non-polar? Non-polar. Cancellation for the 4, net 0. In this case, one bond towards chlorine and one towards chlorine, net effect in the middle, right? Here also in this direction, net dipole moment 0. The only option is 4th. Now let us see that how it is there. On oxygen, children, this is sp3 hybridized and this is sp3 hybridized. If we are using Vesper theory, if you are using the diagrammatic analysis of Vesper theory with lone pairs, there are 2 lone pair of electrons on oxygen, there are 2 lone pair of electrons on oxygen and 2 bonds. So the structure of water molecule is bent. Here also it is bent. Although you might expect that electron density towards oxygen from benzene will cancel it out. But no, individual OH bonds will have some dipole moments which are not cancelling out, because these are not in a straight direction with respect to each other. Like this molecule is planar, this is not a planar molecule, this is a non-planar molecule because of sp3 hybridization and involvement of 2 lone pair of electrons come into play, right? So the bonds of OH and OH will definitely lead to the development of some polarity in the molecule, right? So cancellation is not possible in case of 4th one. So correct option will be 4th one. Right, children? Next question. Next question is we have a diagram here. So next question, almost 28th question. Please check out the numbers. So we have this question here. We have nitrogen here, bonded to hydrogen. Question is, in this molecule, what is the hybrid state of nitrogen? The hybrid state of nitrogen in the molecule is, options are sp2, sp3, sp3d2 and sp. You can see that nitrogen has made how many bonds? 3. There is still one lone pair of electron on nitrogen. That makes it 4. So correct option will be sp3. So second option will be correct option, because there are 4 single bonds that nitrogen can make. Already it has made 3. With one lone pair it can make one more bond. So total number of bonds it can make is 4. So hybridization will be definitely sp3. Clear, children? Question next. The shape of I3 minus molecule. Question is, what is the 29th question? What is the shape of sp3? Sorry, what is the shape of I3 minus molecule? Now, how can you get I3? There are many ways of getting it. Suppose one is Ki plus I2 results in the formation of K plus I3 minus. One of the iodine is a central atom here. So I will draw the normal Lewis structure for this I3 minus molecule. So first of all, we will see the options. What is the shape of I3 minus molecule? Linear. Then second one is bent. Third one is pyramidal. And fourth one is seesaw. Correct. Let us see. I3 minus. How is the valence of the I3 molecule minus stabilized? It is I 1, 2, 3, 4, 5, 6, 7, 8. There's a negative charge on one iodine. Right? So how many total iodines are there? If you can see that clearly. 3 iodines. Now how it will be? Iodine has made one bond with one iodine and one more bond with one iodine. Total number of electrons on this iodine, how many are there? It has made use of one electron, right? One is bonded to iodine. One is bonded to iodine. Total how many electrons remain on iodine actually? There are 7. Total how many remain? 5. But it is I3 minus. So central atom will have one negative charge on it. So it will be 1, 2, 3, 4, 5, 6. Clear or not? So central atom, if you can see, has how many lone pairs? 3. And how many bonds? 2. Total 5. Hybridization will be sp3d. One more way to do it is, children, which we have learned already. What is that? I3 minus. Tell me, central atom iodine. How many valence electrons? Clear. How many valence electrons? 7. Gained 1. 8. How many bonds made? 2. Remaining electrons 6. That means 3 lone pairs. And how many bond pairs? 2. Total 5. Hybridization sp3d. Now, a simple thing to all of you, which all of you remember very well. Tell me, whenever there is sp3d hybridization and you got lone pair of electrons and bond pair of electrons, how do you assign it? How do you align it? Lone pair of electrons are given in the plane, equatorial positions, and bond pairs are given at axial positions. I will do the same. So I am giving one lone pair in the plane, one lone pair in the plane, one more lone pair in the plane. Triangle complete or not? Or triangle complete or not? So triangle part is complete, means triangular bipyramidal is the shape. I have completed the triangle. What remains there? 2 bonds. One will be above the plane, one will be below the plane. Lone pair only determines shape but does not participate in the shape. I am removing the lone pair of electrons now. Yes, so I have removed lone pair of electrons now. Have a look. What is this one? Iodine. What is this one now? Iodine. What is this one now? Iodine. Tell me the shape of the molecule. It is linear. So correct option will be option 1. It will be linear. Clear, children? Did you get it? Very good. Yes. Next question. I'll just take some typical questions now. Which of the following is not a correct statement? Which of the following is not a correct statement? Number 1, multiple bonds are always shorter than corresponding single bonds. This is correct, because double bond or triple bond is shorter than single bond. This is correct option. Option 2, the electron deficient molecules can act as Lewis acids. Yes, electron deficient atoms means either they have positive charge or they have vacant orbitals. So what is Lewis acid? We can accept an electron pair. So once there is a vacant orbital, acceptance of electron pair becomes easier. Thus it can definitely act as a Lewis acid. This is correct as well. 3, the canonical structures have no real existence. True, because resonating structures, actual structure is in between all the resonating structures. That is hybrid structure. Correct. So the structures individually you are showing, they are not existing. They don't exist in real time and you cannot isolate those. This is correct as well. Every AB5 molecule does in fact have square pyramidal structure. every AB5 molecule does in fact have square pyramidal structure. This is not correct. AB5 means hybridization can be sp3d. Is it clear? How many bonds it has made? 5. So it means sp3d. Now it is telling you every time you have AB5, does it have square pyramidal shape? No. We need to see lone pairs and bond pairs into consideration. It will have square pyramidal structure only when there is one lone pair and there are 5 bonds made. Because then hybridization will be sp3d2. sp3d2 means you have got square planar bipyramidal. But one of the position out of plane will be taken by what? Lone pair, which I will not mention here at all. So I will show only 5 bonds. Once I have shown 5 bonds, you tell me what will be the shape of the molecule. Square planar pyramidal. Yes or no? Will it always have square pyramidal shape? No. It depends upon the number of lone pair of electrons and bond pair of electrons respectively. So obviously option 4th one is the wrong option. Correct, children? Keep reading hard. Thank you. Have a good day.